So welcome to our lesson 11, and today we shall look at wheel and axle. Okay, so this is a wheel and this is an axle. The wheel and axle system also is a form of simple machine that helps us to do work easily and in a more convenient way. Instead of you getting into the well, getting into the kisima down there, and then coming up with water, we need to fetch that water in a simpler way and a more convenient way. And for that reason, we may use a wheel and axle system. The wheel in this case has a very big radius, capital R, and the axle has a small radius, small r. When I apply effort and make one revolution, even the axle will make the same revolution. When I apply effort and I make the wheel to rotate once, the axle will also rotate once. If I assume the radius of the wheel is capital R and the radius of the axle small r, and looking at it from this end view, you can see this is the small circle representing the axle, and this is the bigger wheel. Okay? If I assume the axle has small radius r and the wheel has capital R as radius, then distance moved by the wheel will be the circumference 2 pi capital R. The distance moved by the load that is attached to the axle will be 2 pi small r. And therefore, my velocity ratio, distance moved by the wheel over distance moved by the distance moved by the wheel, distance moved by the load, distance moved by the load will be 2 pi capital R, because that is where effort was applied, divided by distance moved by the load is attached to the axle, whose radius is small r, will be 2 pi small r. So circumference of the wheel divided by circumference of the axle will give me r, capital R over small r, because pi and pi will cancel. Okay? So we know now velocity ratio of the wheel and axle is basically the radius of the wheel over the radius of the axle. Okay? Let us look at an inclined plane. Let us focus the camera to the inclined plane. There, I think there is okay. An inclined plane. So what is an inclined plane? It is just a flat material, okay? A flat material like a piece of wood, okay, which is inclined at an angle to help you do work in a more easier way and convenient. So it's just a piece of material like a piece of wood that makes an angle to the horizontal. I have said, suppose this is my piece. I put it at an angle to horizontal. So the angle it makes, let it be theta. If I apply force F from the bottom to the top, thereby covering distance L, then the distance moved by effort will be L. In so doing, the load will have covered a vertical distance small h. Okay, small h. And therefore, velocity ratio is distance moved by effort over distance moved by load, which is equal to L over h. Distance moved by effort is L, distance moved by load is h. Note, Pythagoras and SOHCAHTOA can come in handy in this situation. Why? Anytime you are dealing with a triangle, and more so right-angled triangle, we can get lengths using Pythagoras. We can also get lengths using SOHCAHTOA. I hope you understand SOHCAHTOA there. So why am I saying that? Velocity ratio is L over h. This is a reciprocal of sine theta. Why? Look at this. Sine theta is basically h over L. Opposite over hypotenuse. There is h over L. So if you take reciprocal of both sides, or if you like, cross multiply, L times sine theta is equal to h. Okay? And I want to have L over h. So I'll divide both sides by h, and then divide again both sides by sine theta. Then you will end up with L over h is equal to 1 over sine theta. In other words, I can be asked, what is velocity ratio? Instead of looking for L over h, I just get the reciprocal of sine of the angle. Remember, this angle is to horizontal, is not the angle to the vertical. So you can also be tricked by this angle here. This angle here, up here, is angle to the vertical. But this is the angle inclined make to the horizontal. This is the angle it makes to the vertical. So if I give you 30 here, don't rush and say 1 over sine 30. No. You have to understand, where does the formula come from? What are the correct solutions and what do you do? Okay? And now I take you to the bicycle. Okay? I am taking you to the bicycle. I want you to concentrate on the bicycle now. Okay? I want you to concentrate on the bicycle. I want to concentrate on the bicycle. I want to show you something small about velocity ratio and the bicycles. Okay? So let me draw first a small figure here that will show us this is a rear sprocket. I just do that, a rear sprocket, and this is the chain wheel. This is where the two